Good day, grade 10s. So this is another video on electrostatics. So we will do 2 or 3 questions on electrostatics, on exam questions like revision questions. And then after that we will move to waves, and then after waves we will move to term 2 topics. So this is part 1 of electrostatics. So let's look at the question and do the following questions. This is a November question, question 10. The question says, the statement says, 2 small identical spheres, A and B, are suspended on a long silk thread as shown in the sketch below. The spheres carry charges of 3 times 10 minus 6 coulomb. That is charge A, and minus 2 times 10 minus 6 coulomb. That is sphere B. So these are the 2 charges, A and B. The other one is positive, the other one is negative. So let's look at the questions now. Now question 10.1 says, which sphere has an excess number of electrons? The word excess means more. Which sphere has more of electrons between A and B? Now let's go back to our grade 9 knowledge. In grade 9, we said if you have 2 spheres, let's say you have sphere A, and then you have the second sphere, let's say that is sphere B. So this is sphere B. So let's say that sphere A has 5 negative charges and 2 positive charges or ions or particles. And then sphere B has 5 positive and has 5 positive and 2 negatives. So if you look at the net here between minus 5 and 2, 5 is bigger than 2, so the net will be 3, which is negative. But if you look on side of B, 5 minus 2 and 5 is a bigger number than 2 and is positive. So we take the sign of the bigger number, so you're going to have a positive 3 as the net. Which means that this B is a positive charge and this A is a negative charge. Why? Because it has more negatives. This one is positive because it has more positive. So every time you see a charge that has a negative, then you know that it has more electrons. That's what you know from grade 9. So on 10.1, they're asking which sphere has more excess or more electrons. We know it's sphere B, because sphere B is negative 2 times 10 minus 6. So we said 10.1, the answer is B. 10.2, the 2 spheres are allowed to touch. Will the electrons be transferred from A to B or from B to A? Which sides are electrons going to move, from A to B or B to A? From our previous example, we know that electrons are going to move from A to B. Why? Because A is negative. So electrons are moving from the charge that is negative to a charge that is positive. So we write that here. We say They are going to move, in this case, from B to A. They are going to move this way, from B to A. So that is 10.2. B to A. Yeah, so now let's go to 10.3. The spheres are now separated. Calculate the new charge on sphere B. The new charge on sphere B. Now, what is a new charge? A new charge is like, imagine you, let's say initially we have sphere A and sphere B. Sphere A was 3 times 10 minus 6 coulombs, and sphere B was minus 2 times 10 minus 6 coulombs. So that sphere B is minus 2. So they will come into contact. In other words, they will unite, because this one is positive, the other one is negative. So they will attract each other. They will attract each other. And then you're going to see something that looks like this between A and B, the one that is positive and the one that is negative. Now, when they are in contact, what's happening there? They are sharing electrons. They will share electrons up until they become equal in magnitude of charge. So they will share electrons up until they are equal. They are equal. So when they are equal, now what's going to happen after? Now what's going to happen after is that they will have now the same amount of charge, and they will do what? They will repel each other. They will push each other away, because now they have the same amount of charge and the same amount of electrons. So here we know that they will repel. So we call this now, remember this was Q initial for A, that was Q initial for B. After contact now we have Q final for A and we have Q final for B. This Q final, they also call it Q new, the new charge, and this one is the new charge for B. So this is happening after contact. So they said, now let us calculate this new charge. 10.3, the spheres are now separated. Calculate the new charge on sphere B. So let's do that now and see what we are going to get. So we have the formula to find the new charge. The formula says Q new is equal to QA plus QB all over 2. What is A? A is 3 times 10 negative 6 plus B is minus 2 times 10 minus 6. Then we're going to divide by 2. So let's take the calculator and see what we are going to get here. So we form a fraction, open a bracket, 3 exponent negative 6 plus, open a bracket, negative 2 exponent negative 6, then denominator is 2. The answer is 5 times 10 to the power negative 7. So we have 5 times 10 negative 7 coulombs. This is joule nu. In other words, both of these charges, A and B, they are going to be 5 times 10 to the power negative 7 coulombs. This one also will be 5 times 10 to the power negative 7 coulombs. Both now they are positive. And this one is also positive. So they are positive and they are pushing each other away. That's why they repel each other, because they are positive. So this is what they wanted us to calculate, the joule nu or the joule final of charge B. So now we go to the next question. Calculate now the number of electrons transferred during contact. So as we said that B is the one that is going to transfer electrons to A. B is the one that's going to transfer electrons to A. How many are these electrons now that B is transferring to A? So in order for us to know the number of electrons that B transferred, we need to know first how much of B did B transfer. Look, initially this was B, negative 2 microcoulombs, or negative 2 times 10 to the power 6. But after contact now, look at B. B now is positive 5 times 10 to the power negative 7. There is a change here from the initial amount of charge of B and the final amount of charge of B. So we need to know what is this difference. What is this difference? What is joule transfer of B? How much did B lose? Joule final minus joule initial. We need to know how much was lost. How much B lost from the contact it has with A. So let's find that joule transferred. How much charge was transferred? So we do that one first. So we say 10.4 joule transfer. We are talking about B now. Is joule final minus joule initial for B. Need to know we are talking about B here because it's B that lost electrons. So let us look at this calculation now. So how much is the final for B? So we know B joule final is 5. It is 5 times 10 to the power negative 7. What is joule initial for B? It is negative 2 times 10 negative 6. So that is the final for B is 5 times 10 minus 7. What is initial? Initial is minus 2 times 10 minus 6. So we are going to take a calculator and then we're going to punch this and see what's the answer. So we have 5 exponent negative 7 minus negative 2 exponent negative 6. So we see that B lost 2.5 times 10 minus 6. 2.5 times 10 minus 6 coulomb. This is the amount of charge that B transferred to A. So This is the amount of charge that B transferred or shared or gave with A to A. So to find now the number of electrons that B transferred to A, we're gonna take that Q transferred of B and divide it by the quantization of charge. Then the amount of charge that was lost, we said, is 2.5 times 10 minus 6. The quantization of charge is 1,6 times 10 to the power negative 19. Then let's find how many electrons were transferred. 2.5. Okay, let's form a fraction. Is 2.5 exponent negative 6 divide by 1.6 exponent negative 19. So the number of electrons is 1.56 times 10 to the power 13. 1,56 times 10 to the power positive 13 electrons. So this is the number of electrons that were transferred by B during contact. So that is the end of our question. Yeah, that was the last question. So now I'm going to do the next question on electrostatics, which will be our part 2.